Welcome to the DIY Honda Garage channel. The DTC P16BB refers to an issue with the alternator's B-terminal circuit where a low-voltage condition has been detected. This specific error code is significant as it indicates a potential failure in the electrical system that can affect the vehicle's overall performance. The alternator is responsible for generating electrical power to recharge the battery and power various electrical components of the vehicle while the engine is running. The B terminal of the alternator is critical as it provides the main power supply to the vehicle's electrical systems. A low voltage reading could signal a variety of issues, including wiring problems, poor connections, or even faults within the alternator itself. The Honda CRV from 2011 to 2016 is particularly sensitive to these types of faults, which can lead to various electrical malfunctions and drivability concerns if not resolved promptly. The error description for DTC P16BB indicates a problem specifically with the alternator's B-terminal circuit. This circuit is crucial for delivering electrical power generated by the alternator to the vehicle's systems. When this circuit is reported as low voltage, it signifies that the alternator is not providing an adequate electrical supply, which can lead to battery drainage and operational issues for electrical components. The alternator itself is usually located at the front of the engine, near the drive belt, and the fuse relay box is typically situated in the engine compartment. The failure in this circuit can stem from a variety of sources, including loose connections, damaged wiring, or an installed alternator. Understanding the role of these components is essential for effectively diagnosing and remedying the issue to ensure the reliability of the vehicle's electrical systems. Several possible causes are associated with the DTC P16BB, which help diagnose the issue effectively. Firstly, loose connections or terminals at the alternator or the underhood fuse/relay box can create poor electrical contact, leading to lower voltage readings. Additionally, an open wire in the harness connecting the alternator to the fuse/relay box might exist, disrupting the flow of electricity and causing the low voltage condition. Lastly, a faulty alternator itself may not be able to produce sufficient electrical power, contributing to the problem. Each of these causes is critical to inspect, as addressing them will help in restoring the system to its proper functionality. The correct identification of these issues is essential for successful troubleshooting and repair. When dealing with DTC P16BB, certain symptoms may present themselves, indicating an underlying issue. Drivers may notice dimming headlights, which can occur especially when electrical load is high, such as during use of the air conditioning and high beams. Additionally, the presence of a battery warning light on the dashboard serves as a clear indicator that the electrical system is struggling. Other electrical accessories might also malfunction, such as power windows or the radio, reflecting the inadequate power supply from the alternator. Observing these symptoms might not only help in pinpointing the issue, but also signal when immediate attention is needed to avoid further complications. Identifying these clues can lead to a more efficient troubleshooting process. The first step in troubleshooting DTC P16BB is to turn the ignition switch to the on position without starting the engine. This action allows the vehicle systems to initialize, making it possible to run diagnostics. After this, it is essential to clear any stored diagnostic trouble codes, DTCs, using the Honda Diagnostic System, HDS, which resets the vehicle's onboard computer and prepares it for a fresh diagnosis. Following the clearance, start the engine and observe it as it runs under specific conditions to further assess diagnostic data. This preliminary action will help in determining whether the DTC reappears, providing insight into the status of the electrical system. If the P16BB code indicates again, then it confirms that a problem exists that needs further investigation. The second troubleshooting step involves checking for poor connections or loose terminals, specifically at the alternator and at the underhood fuse relay box, particularly focusing on the +B line. Poor connections can significantly impact electrical flow, leading to voltage drops and causing the DTC P16BB to trigger. Proper inspection requires ensuring that all wiring harnesses are secure and that terminals are clean and tightly attached. If any connections are found to be loose or corroded, they should be repaired or replaced as necessary. After addressing any issues identified during this inspection, perform a repair verification to confirm that the circuit functions properly. This step is essential to establish a reliable foundation before moving forward in troubleshooting the electrical system. In the third step of troubleshooting for DTC P16BB, the focus shifts to checking for any open wires in the +B line, especially within the engine harness that connects the alternator to the underhood fuse relay box. An open circuit, due to a break or fault in the wiring, can prevent adequate power flow that is essential for vehicle operation. Using a multimeter, measure continuity throughout this wiring to identify any breaks or shorts. If the harness is found to be intact, the next step involves replacing the alternator, which may be malfunctioning if it cannot generate appropriate voltage. If a fault in the wiring is discovered, appropriate repairs should be made immediately. Ensuring a proper connection can rectify the low voltage condition and restore functionality to the electrical system. After making repairs related to the P16BB code, verification of the repair is crucial to ensure that the problem has been resolved. Begin by turning the ignition switch to the on/2 position, preparing the vehicle systems for resetting. Utilizing the Honda Diagnostic System, HDS, to reset the powertrain control module, PCM, is necessary as it clears any log data and allows the system to reinitialize. Performing the PCM idle learn procedure is an important subsequent action. This process enables the system to adapt to any changes made during repairs and ensures optimal engine performance. Once these preliminaries are executed, start the engine and check for DTCs under specified conditions to verify that the repairs were successful. Monitoring the DTCs post-repair will provide confirmation that the electrical system is functioning as intended without any returning issues. Preventive maintenance is essential to minimize the risk of encountering issues like DTC P16BB in the future. Regular inspection of electrical connections, especially at the alternator and fuse relay box, can identify and prevent loose connections and corrosion that may lead to low voltage problems. Moreover, maintaining the battery's condition is equally critical, as a failing battery can add undue stress on the alternator and electrical system. Scheduling routine alternator checks can also aid in early detection of potential failures, allowing for timely interventions. Keeping the electrical system in optimal health not only enhances vehicle performance, but also extends the lifespan of vital components, ensuring reliable operation over the years. Adhering to these preventive measures can significantly reduce the chances of electrical system-related issues from arising. In summary, the DTC P16BB represents a significant concern regarding the electrical system of the Honda CRV from 2011 to 2016, specifically linked to the alternator's B-terminal circuit. Throughout the troubleshooting process, we identified potential causes such as loose connections, open wires, and a faulty alternator that needed addressing. The importance of performing repair verifications cannot be understated, as it confirms the resolution of the issue and ensures that the vehicle functions optimally going forward. Additionally, Embracing preventive maintenance practices will safeguard against similar issues arising in the future, promoting prolonged reliability of the vehicle's electrical systems. Keeping vigilant and proactive in maintenance helps in achieving a seamless driving experience without interruption from electrical failures. Please like and subscribe to the channel. See you next time.